Hi everybody, this is Shivakumar. Today we are going to discuss about collisions. Right? So in previous class we have already discussed about when there is a net external force is 0. Then the acceleration will be equals to 0. And then what happens? The velocity of the system will be equals to the constant. Right? So in previous class we have discussed that F net of a system is equals to 0. That means the acceleration of the system is equals to 0. When there is acceleration is equals to 0, that means the velocity will be the constant. So velocity will be velocity is constant. Right? So here, how do we got this? By taking F is equals to ma. So here what happens? F we are taking system and acceleration is also taking the system. So for that reason, we can tell that when the force of a system is equals to 0, that means the acceleration of the object, the acceleration of the system is also equals to 0. When the acceleration is equals to 0, then the velocity is equals to the constant. How? We know that acceleration is equals to v minus u by t. So if this initial velocity and this final velocity are same, then what happens? The acceleration will be equals to 0. For that reason, the acceleration of the system is equals to 0. So then what happens? The velocity is equals to the constant. That means the momentum is conserved here. The momentum is conserved. So momentum is conserved means what? That is nothing but the initial momentum and the final momentum both are same. So then what happens? The initial momentum of system is equals to the final momentum of the system. Okay, so here this we have discussed in our previous class. Now coming to the collisions. Collision means what? So here the collision is nothing but the interaction of any two objects or any objects. The interaction between any objects. Okay, so that is called the collision. Okay, so the basic definition of the collision is that the definition of collision. It is the interaction between any two or more bodies within short period of time. Short period of time is called collisions. Okay, so here we are having that the basic definition of the collision is the interaction between any two or more bodies within short period of time is called collisions. So the examples of the collision. So let us take a best example, that is that the bat is hitting by the ball, right? So in cricket, the ball and bat are getting hit. So here what happens? The ball is getting hit by the bat within a short period of time, right? So we say that is a collision. Yes, of course we can tell that is the collision. The interaction, here we are having the interaction between the two objects. It may be here we are having ball and bat. Here we are having two objects. Here what happens? The bat is hitting the ball within a short period of time. So for that reason, we can say that is the collision. So another example. So you can take that your mother is beating you, right? Your mother is beating you on your chin. So then what happens? This is, let us take, this is one object and this is another object. We are taking two objects. So then what happens? This object is getting hit by this object. Okay, then what happens at the time? Then here we are going to get a very good collision here, right? So here what happened? Another example is that the fighting, beating by your mother, beating by your mother on your chin, on your chin. So then what happens at the time when your mother is beating you like this, right? So then what happens? It is within the short time period, then we are going to do like this. Right, then what happens? Here, this object is coming with a certain velocity and this object is in rest position. Then what happens? This is getting contact with this object, then both are moving. Right? After hitting this, it will not be like this only. Right? So then what happens? After hitting this, then both are will move like this. Right? Have you observed this or not? If you are not observed, then go and check it with your mother. Okay, ask your mother to beat once. Okay, then you will understand what is collision. Okay, so right. And another example, accidents. Accidents. Have you ever seen the accident? Accidents. So let us take a tracker. Okay, tracker. Right. So the tracker is in rest position. Let us take the tracker. Track is in rest position. Okay, so a person is coming on the bicycle, okay, and he is having more velocity, he is having some velocity, okay, it may be more or less anything, okay. So then what happens here, the cyclist will come in with a certain velocity, and here what happens, here this cycle will hit by this tracker, right, this cycle will hit by this tracker. Why? What happens at the time? Then here also we can tell that is a collision taking place here. So then what happens? This object is interacting between these two. Interaction is takes place here. So for that reason we can tell this is also one type of collision. So here what happens? Within short period of time, what happens? This velocity is going to be changed here. Right? So have you ever observed this in any type of accidents? Have you ever seen any accidents? Yes, tell me. So best example, another one also we are having. So fighting with your friends. Fighting with your friends or pushing your friend. So in the class what happens if a person if a person don't want to be silent, so then what he will do, he will just push his friend. So then what happens, within a short period of time the interaction between the two bodies is going to be taken place and that person is moves. Then what happens? The collision is occurred there. Okay. Another example, you can take a bullet. Gun. You know the gun? Gun is fired. Right. So then what happens? The bullet will hit the man. Hit the person. Let us take person. Okay. Hit the person. Then what happens? After hitting the bullet inside of the man, then the man will strike like that. Right? Have you ever seen in the movies? Yes, we have seen in the movies. Right? So when a gun is fired, the bullet, then the bullet comes with a certain velocity. And if the person is like this, then when the bullet comes here, then what happens? This object, here also we have to consider this is an object, right? So then what happens? This object and bullet both are here intersecting in my chest. Okay? And then what happens? Then I will go like this. Why? Why? Because now we are going to learn in this chapter that is called collisions. Okay, so let us take a best example, or in our physics terms, let us take a free body diagrams. We can take the free body diagrams. So here let us take an object A. So an object A having mass ma, moving with the certain velocity ua. Another mass is also there here. So let us call that is B. This object is having a mass mb, and this is moving in this direction with the VB. So here tell me that this object has to be collided with the B. Then which velocity should be the more, VA or VB? Tell me. Let us take if VB is greater than UA. So UB is greater than UA. So the velocity of B is more than the velocity of A. Then what happens? Then this object will move fast and this object will move slowly. Then will be a collision takes place here? No. Here the velocity is not, here the collision is not going to be taken place when the velocity of B is more than the velocity of A. So this is not possible. Not possible in this situation. Let us take here UA is more than UB. So the velocity of object A is more than the velocity of object B. Then will B get any collision here? Yes, definitely we are going to get the collision here. So then what happens? This object, this object is coming with certain velocity UA, and this object is getting hit by this object. So here A and B. So here this is collision taking place. This is before collision. So after getting collision, then this object will move like this. So this object A and object B, and this is moving with the VA, and this object is moving with the VB. And is there any change in the mass? No, there is no change in the mass. Here what changes have been taken place? Only the velocities are taking changes here. Only the velocities are changing. So here what happens? The first one is the initial velocity of UA is UA. Initial velocity of A is UA. Initial velocity of B is UB. And the final, here what happens after collision? That's right. After collision, what happened? The velocities of the objects are changing. Right? So, is there any change in the mass? No. There is no change in the mass during the collision. Right? So like this we can think. So let us say here what happens. This is my initial. Right? So here what happens, this object is deformed. So let us take here you see an object A and object B is there. So when this object is coming with certain velocity UA and this object is also having some velocity UB. So then what happens when the two objects are getting collided, then there will be a deformation is going to be taken place here. So the deformation is going to be taken place. So here the deformation of object is going to be taken like this. So here the shape of the object is getting to be changed. The shape of the objects A and B are getting to be changed in the collision taking place, or we can also call this is deforming state. So this is my deforming state. So here this is my before collision, this is my deforming state, and this is my reforming. So here, from here to here, we are having this is deforming, F-O-R-M-I-N-G, deforming period, and from this to this, here we are having reforming period. Okay, so here what happened? This is deforming period, and after collision, then that will be the reforming period. So let us take here. So when this object is coming with certain velocity and hitting this object B, then what happens? A small change in the shape will be taken place. Okay, so then what happens? Here we are giving certain velocity. Okay, then what happens? Here this object is also having some velocity, right? And this object is also having the force of deformation force is opposite to this A. The force is coming, right? Restoring force. Let us take the restoring force. So then what happens? If we are giving some force, some velocity of this object, then the restoring force of B is coming towards this direction, right? Okay, so let us draw here. Okay, so here we will take deforming period. Okay, in deformation period. Okay, so here what happens in deformation period? Now this is my final, right? So here what happens? At the point of collision, there will be the maximum velocity of the two objects. Are you getting? The maximum velocity of the two objects are at the deforming state. Okay, so let us take the deformation period. Okay, so here we can take an object of A, okay, another object of B. So these two are moving with the UA and UB, right? So then what happens? This object will move here, right? So then what happens? This object is getting change its shape. Okay. So here what happens? The change of shape is going to be taken place. So this is A and this is B, right? So here what happens? This object is moving right this direction. So then what happens? Another force, that is the restoring force, is also coming from this side. Okay. So here what happens? This is the period of deformation. So we can call it, that is deformation force. Restoring force I am taking as deformation force. So we know that deformation force, that is the force, right? So force is that change in momentum per rate of change of momentum, that is right. So for small change here we need to get d dt, right? So for momentum we are going to get this one, right? dp, integration of dp is equals to integration of dt. So here what happens? Sorry. Okay, so here what happens? This object is moving with MA, UA. Okay, and here what happens? This object is having the mass MA, right? And here, okay, and here we are having the change in momentum. Change in momentum is how much here? Here it is coming in this direction, right? So here this object A, it is coming in this direction, right? The value of this is d dt. So here what happens? The equation will be equals to MA UA here coming from this direction, right? So minus integration of d dt will give. So here what happens? After this, the A will be like this, right? The A. So let us write here. So d is equals to f dp by dt. Integration of dp is equals to integration of dt. We have taken this. So for this object, the resultant will be A, right? So this will be moving with a certain velocity u, and this is ma. So the resultant will be equals to MA, right? So MAU. So let us take, this is my equation 1. Okay, so here what happens? Deformation force of A we have taken, right? Now 2, that is deformation force, deformation period. In deformation period, the B rule here we are going to see. So here the object B is here, right? So it is moving with the velocity UB, and this is having the mass MB, right? So here what happens? Here this object is getting hit by, so this is B, right? So this is A, right? So then what happens? This object is getting hit by this, right? So here what happened? The momentum, here also we are getting the deformation force, right? So the deformation force is acting in this direction here for B. For B, the deformation force is acting in this direction. So here we got the deformation force. The momentum of the deformation force is equals to integration of d dt. So here this object is d dt. This is momentum, right? So here the resultant of B will be like this. So B is moving with U. This is NB, mass of B. Okay, so the equation of this will be equals to NB UB plus integration of d dt gives NB U. So this is my equation 2. Okay, so here what happens? The deformation in deformation period, we are having MAUJ minus integration of dt is equals to MAU. Integration, sorry, and next equation is MBUB plus integration of d dt is equals to NBU. So we got these two equations in deformation period. Okay, now we'll see the deformation period, sorry, reformation period. We'll see reformation period. Reformation period. Okay, so reformation period will start from the collision to the final position. So then what happens at the time of the collision? We are having that A. Let us take the object of A. So here we have the collision is taking place here. So from here we need to take. So this object, let us take a bigger. So here for A object, so this is my A. Okay, so this object is moving with a certain velocity U, right, of A. So here we see the deformation force is taking place here. Now we'll see the restoring force of A. Okay, so then what happens? Then here A is getting restored. So here what happens? By the Newton's third law, here what happens? When the deforming force is applying on this side, then this force is also give the same force, right? By the Newton's third law, every reaction has equal and opposite reaction. So how much force we are getting? The same force we are going to give from this side, right? So then what happens in reformation? So the force is getting here, right? So here the restoring force I am taking R. Okay, so the R restoring force is dP by dt. So for dP it's R dt. Okay, for the momentum here we are taking R dt. So here we are taking MAU plus, and here we need to take R dt. R dt is my change in momentum. My momentum here. Sorry, my momentum. So here R dt. So this gives the object A moves with velocity VA, having the mass MA. So here in the total collisions, the mass of the object is not going to be changed here. So then what happens here? MAU, this is momentum, okay, and this is also momentum, and the final momentum is MAVA, right? So the VA is my final momentum of this object A. Okay, so let us consider this equation 1, 2, and this is 3. Okay, for A we got this equation. For B the restoring, the reformation period. So here what happens? The B is like this, right? B. So then what happens here? Here you see, here how much force we are getting, the same force here we need to give this, right? So for that reason, then what happens? From this B, here we are getting the same force. Okay, so here what happens? This the restoring force. So the momentum is restoring force towards this direction, and this is moving with U, and here having the MB, right? So the resultant will be the B moving with velocity VB and having the mass MB. So here the momentum, the changing, the total momentum here we need to calculate. So this what happens? MB U minus integration of R dt. R is my restoring force or reformation force. Okay, so this will be equals to MB VB. So this is my equation number 4. So now what should we need to do? We need to add all the equations. We need to add all the equations. Then we are going to get a beautiful formula. Add all the equations. So then what happens? The first equation is MAUA minus integration of deformation momentum is equals to MAU, and next MBUB plus integration of dt is equals to MBU, and next MAU plus integration of restoring momentum is equals to MAVA. Next MBU minus R dt is equals to MBVB. Now we need to add all these. Then what happens here? Here we are going to get MAUA plus MBUB plus MAU plus MBU. And next here friend, MAU plus MBU plus MAVA plus MBVB. Okay, so we got this. So here you see MAU, MBU, MAU, MBU. So we'll both get cancelled out. So the remaining is equals to MAVA plus MAUA plus MBUB is equals to MAVA plus MBVB. So here what happened? Here the initial momentum. So here what happens? We have taken the two objects, two balls. Okay. So the momentum of that is equals to the two objects is equals to MAUA plus MBUB, and the final momentum is that MAVA plus MBVB. So here what happens? Here the initial momentum of the system is equals to the final momentum of the system. Final momentum of the system. So MA is equals to MAUA plus MBUB is equals to MAVA plus MBVB. So here this velocities are vector quantities, right? So the velocities are having the directions. So here what happens? The initial momentum is equals to the final momentum of the system are equal. Okay, by this we got all these things. Okay, now we are going to discuss about coefficient restitution. So it is denoted by E. Okay, so it is the definition of this coefficient of restitution is that the ratio of velocity of separation, to the velocity of approach. Okay, so the coefficient of restitution is that the ratio of velocity of separation to the velocity of approach. So here we can take an object A, an object B, and here what happens? This is moving with the UA and this is moving with the UB. So here they both collide, and then after collision, the object A is moving with the VA and the object B is moving with the VB. Okay. So here what happens? The velocity of separation. So velocity of separation. So here what happening? Here before collision. So here what happens? The velocities are getting approached. So this velocity is getting approached. So then what happens here? This velocity is velocity of approach, right? And here you see, here after getting collide, these two masses is moving, right? So then what happened here? Here the velocities are here getting separated, right? So velocity of separation here. So here VB minus VA, and here you can take UA. You can take here UA minus UB. So here what happens? The coefficient of restitution is that velocity of separation. Velocity of separation is that VB minus VA by UA minus UB. So these are our vector quantities. Okay, so the coefficient of restitution E. Okay, so why should we have to take this E? Why? Because to identify the types of collisions. Now we'll see the types of collisions by using the E. E is the coefficient of restitution. So we'll see the types of collisions, right? Okay. Now collisions are divided into two types. On first one is on the basis of line of motion, and on the basis of energy. Okay, so here the first one, here we are having two. So first one is head-on collision. And next one is oblique collisions. Coming to this, on the basis of energy, first we are having elastic collision. And next one is inelastic collision. And third one is perfectly inelastic collision. Okay, so here in elastic collision, the E value E is that we have discussed that the coefficient of restitution. So here we can take E is equals to 1 for elastic collision, and for inelastic collision the E will be equals to E should be greater than 0 and less than 1 for inelastic collision. For perfectly inelastic collision, the E value should be equals to 0. Okay, so E value here we are having 1. Okay, for elastic collision, the coefficient of restitution is equals to 1, and the inelastic collision is the coefficient of restitution is equals to, it is in between 0 and 1, and the perfectly inelastic collision, the E value should be equals to 0. So first we will see head-on collision, and next we will see oblique collision. So first we will see head-on collision. So what is head-on collision? Head-on collision. Head-on collision. So here in this head-on collision, Here what I meant, the base of line of motion. So the line of interaction and line of motion both are in the same direction. Okay, so let us take an object is moving. So first we will write the definition, right? So here what happens, the line of interaction and line of motion are in same direction. Okay, let us take an object. Okay, so here what happens, an object is there having certain mass ma, we will take ma, and here another object is also there, it is also having the mass ma only. So this maybe have any other. Okay, let us take in B. Okay, so this object is coming and hitting this object B. Okay, with the velocity ua, and then if we are considered if the velocity of B is equals to 0, okay, then what happens, this object and this object A and B both will move in the same direction. Okay, so here what happens, this object A and object B. So object B is moving with certain velocity and object A is moving with a certain velocity. So here what happens, the line of interaction. So here what happens, the line is not changed here. So the line of interaction and the line of motion both are in the same direction. So for that reason we can say that is head-on collision. We can also call as one-dimensional collision. Next, coming to the oblique collision. Okay, so here what happens, in head-on collision, the line of interaction and line of motion are in the same direction. Now coming to the oblique, the line of interaction and line of motion are in different direction, are not same, are in different directions. Okay, so let us take, here we are having an object A, here we are having an object B. Okay, so then what happens, this object is moving in this direction with UA and this object is moving with UB, or we can also take Z rest position. So okay, so here what happens, this object A is coming and getting collision here. Then after, here what happens, after getting the collision, these objects, so here the object will move, A may be moved in this direction, B may be moved in this direction. So then what happened here, the direction of motion is changed here. Here what happens, the line of interaction is in this direction. Okay, and here what happens, the line of motion of the objects are changed here. If line of motion will be equals to 0, will be same means here the object will be moved in this direction. But what happened here, the objects are changed its direction. So for that reason we call this is oblique collision. We can also call this as two-dimensional motion, so two-dimensional collision. Okay, so if we are having more number of objects, it's going to be changed in different types of different directions. Okay, now coming to elastic collision. So elastic collision, now we are going to discuss. So on the basis of energy, we'll see here. Elastic collision. So here elastic collision. So the first thing what happens, the coefficient of restitution is equals to 1. So that means E value is how much? 1. So what is the definition? What is the formula of coefficient of restitution? That is the velocity of separation velocity of separation by velocity of approach. Okay, so here what happened, the velocity of separation by velocity of approach is equals to 1. That means here you can take that v2 minus v1 by u1 minus u2. This will be equals to 1. That means here v2 minus v1 is equals to u1 minus u2. Right? So here if we interchange this, then we are going to get, it's okay sir. So here what happens, this is my relative final velocity and this is my relative initial velocity. Okay, so here what happens, the velocities are same here, the relative velocities, right? So the final velocities and initial velocities both are equal in a system. So for that reason, the momentum is conserved. So here what happens, the acceleration of the system is equals to 0 and the force of the system is equals to 0. There is no external force. So for that reason, the velocities of this are constant. So then what happens? The final velocity and initial velocity of the system are equal. That means constant. So the momentum is conserved here. Right? Okay. So here momentum is conserved. Momentum is conserved in elastic collision, right? Okay, so here what happens, the first one we need, if we are doing any question, first we need to take that in collisions first we need to take the conservation of momentum, okay. Next we need to take E is equals to 1. So before I wrote here something, what is that? The conservation of momentum. We have discussed there, right? So here what happened? The third one is that the energy loss is 0. So the kinetic energy initial of the system is equals to the kinetic energy of system of final of a system. So here in elastic collision, the conservation of momentum, first one we need to take, then after the coefficient of restitution is equals to 1 and then the no loss of energy is going to be taken. So no loss of energy is going to be taken place in elastic collision, right? So in elastic collision there is no loss of energy. That means, see, I am giving some force toward this. So then what happened? Here we got some sound, right? We got some sound. So then what happened? The energy is converted into sound energy. My mechanical energy is converted into sound energy. So here what happens? The loss of energy is there. When I beat this object, then there is loss of energy is there, right? So whenever we are getting some sound, then there is loss of energy is going to be taken place, right? So you see, when your mom hits your chin, right? Okay, then after some time you will rub like this. Why? Because here we are having so your mom is hitting you on your chin. Then what happens? After 1 or 2 seconds, then here you can observe that here we are going to get some heat, right? So let us take, after hitting that, keep your hands on your chin. Then what happens? This side is very cool compared to here. Then what happened? The mechanical energy is converted into heat energy here. Then here what happened? The energy is lost. Here, right? So then what happened here? Here this is not elastic collision. Here why? Because the energy is lost here. So for that reason this is not a elastic collision. Okay. And coming to inelastic collision, it's okay, I will discuss later. And perfectly inelastic collision. So perfectly inelastic collision, in that what happens? So when an object is there here and another object is there, here both are getting collision after the collision, both will move with the same velocity. Both will get attached to each other and move with a certain velocity. That is called inelastic collision. Okay.